Hi, so welcome to another episode of Enterprise MLOps interviews. And today we have a special guest that I've known for quite a while, Ville. Is it pronounced Ville? Is that correct?
Ville, yep.
Ville.
hmm
And you're a former Erlang person,
That's
or
true.
like we had
I
met
guess I can
originally.
always an
Al-
Erlang person. So
Always an Erlang person. And then you were at Netflix for a long time building MLOps platforms, and now you have your own MLOps platform. So do you want to introduce yourself and talk about what you're
yeah,
doing?
no, I think that's like pretty much in the order of importance. So I mean, definitely an Erlang person, a big fan. But yeah, no, I used to lead machine learning infrastructure at Netflix. And well, of course, like many of you probably know that Netflix has been doing machine learning recommendations for a long time, but not everybody knows that there are also like hundreds of other use cases that for machine learning data science that Netflix has, and hence like we had a very pressing need for an MLOps platform, and this was already back in 2017, and like for those of you who you remember 2017, I mean that was before SageMaker, Kubeflows, and so forth. So we had this like a same question that of course many questions companies are facing today, that like how should we do this? So anyway, long story short, like started doing that at Netflix. We had a great team there, and we open sourced this tool called Metaflow, and it was always a bit of an experiment to see if anybody cares. And like it turns out that like a good number of companies cared. So then we kind of like left Netflix to really focus on doing that full time, which is now a company called Outer Bounds, where I'm the CEO and co-founders.
Great. Yeah, that I think your background is very interesting for the time we're in for MLOps, because and I've had a few conversations with people about this, that it feels like a very immature space in a way,
Mm-hmm.
where
For sure.
even products like SageMaker, Vertex AI, Azure ML Studio, Databricks, there's things that are getting put in there that are beta, like
Yeah, for
every
sure.
3 months, right? There's all of a sudden a feature store, like, oh yeah, let's put a feature store in.
Yep.
Like in some sense, I would even call it a jump ball. I guess, to
Mm-hmm.
use an American term, where you just throw it up there, and who knows what's going to happen.
Mm-hmm.
And
Yeah.
so the fact that you built a platform that solved a particular problem in a large company, I think does actually make things pretty interesting from your end. And that would be a question I would have, is like, what are the particular problems that you are solving at Netflix that you think are essentially repeatable for other people?
Right. Right. Well, I think that the interesting fact, and like totally agree with what you just said about the field being very immature. So, but well, I think like two things that are absolutely true. I mean, first, I'm definitely feeling that many companies do agree that these ideas of data science, ML, maybe even AI are here to stay. So, I mean, there's always a kind of a first, like a sanity check question, like that we should always ask ourselves, that does any of this make any sense? I mean, like, are we even like kind of spending our time on anything that makes sense? And I think that there's like a strong sentiment that there's actually a lot of value in these techniques. So, I mean, in that sense, we are onto something. Now, exactly as you pointed out, the tools like for actually utilizing these techniques to produce sustainable business value are extremely immature. And I think it's also I think it's just a kind of a result of the fact that these are still early days. I mean, like for those of you who you remember maybe setting up an e-commerce store like maybe year 2000, 2001, I mean, it was really like quite a painful experience. All the frameworks were extremely immature. Setting up payments, oh my gosh, I mean, like back then was really hard. And of course, I mean, the world is now way different 20 years later. And the same thing with MLOps. I mean, again, I mean, we are onto something that is actually quite meaningful, but I mean, it's still early days. All these, and like as an industry, we don't quite know what is the right recipe. But like, what to your question, that like, okay, so like what are the things that like really kind of like what all companies see is that, well, the problems are equal. I mean, everybody has the problem that even the organizational setup is not clear. Like, what are data scientists supposed to be doing? What are data engineers supposed to be doing? What are platform engineers supposed to be doing? And then of course like the tool chain as well, that okay, I mean, like what kind of tools we need. I mean, do we need an experiment tracking system? Do we need a compute layer? Do we need an orchestrator? Like, and it's a kind of like a big mess of all these tools. Yeah, no, I mean it's kind of at the same time it's definitely frustrating, but at the same time it's quite exciting as well to see how the whole field develops.
Yeah, and I agree with you that because there has been a period of time where people have been skeptical of artificial intelligence. And when I was working at Caltech in the early 2000s, I remember a computer science professor there. I was trying to get advice about artificial intelligence because that was something I was really interested in. And he said, "Don't waste your time."
Exactly.
Basically.
Yeah.
And this was 2002, I think. He was
Yeah.
saying, "Yeah, it's dead. Don't even worry about
Yeah.
it."
Yeah.
But I agree with you that data science, artificial intelligence, for people that are in the space, I think it's very clear that they're not going away. And
That's
it's
right.
not going to be an AI winter, and that the tools, the products that are being developed are, I think, shocking in the effect they're having. I think both good and bad. And like, I think some good examples would be the Copilot tool
Mm-hmm.
from GitHub, and also Code Whisperer from AWS. Those kind of tools, once you start to use them, you realize that there's no way people are going to accept not having those tools
That's right.
because they're too good,
Yeah.
right? And so, yeah, in that sense, I totally agree with you. I think that is not necessarily immature. Like
Yeah.
that some of these LLMs, large language models, are actually very clearly solving problems, and they're going to get better and better and better. But it's obvious the space they fit in. The part that we're maybe talking about a little bit more is that, how do you actually get a team of people
Right.
to work together on a machine learning project? And what are the sticking points, and what, how do you actually do a product? And I think your analogy about the e-commerce is on point, because I do remember that period of time. And
Mm-hmm.
I even remember right before that. So when I was in high school, I used BBSs.
Mm-hmm.
I don't know if you ever used those.
Yeah. Yeah.
Where I dialed in, and I would get into a text, a real, what is it, role playing game, where
Mm-hmm.
you would
Yeah.
ask,
Like
Legend of
yeah,
the Red Dragon,
mods.
and
Yeah.
yeah,
Yeah.
mods, all that kind of stuff.
Yeah.
And then right after that, the internet came alive. And then I remember people that I knew were talking about like DNS servers, and like a DNS server
Yeah.
was like a mythical creature of, it was like DNS. Oh my God.
Yeah.
It
Yeah.
was like a
Yeah.
big deal to set
Yeah.
up a DNS server in like 1995 or something,
Yeah.
and I think this we're like that with
Yeah.
the MLOps tooling, is that we're at the point where it's all very magical, and it will obviously get better.
Yeah, yeah. And like a good example about the DNS, that it's one of those things that like most people today, even like people who run sizable, let's say like e-commerce operations, I mean, they don't care about DNS. They hardly even know like what is a DNS server. And like it's one of those parts of the stack that like it is there, but it has just kind of faded in the background. It is so foundational that there's somebody else who takes care of it. It just works. You don't have to worry about it. And I think that exactly the same thing will happen with all these like MLOps. So many parts of the MLOps tooling that like some parts will just fade away. They don't disappear. They are still there. But I mean, they just become a non-issue. And then the interesting question is that like, okay, like what are the parts that we are looking at today that will actually make a difference even like 10 years from now? And like, what are those things that will fade in the background? And I think that that's also like one big question, that especially like companies who are thinking that like, where should they invest their resources? Like, should they have their own, let's say, engineering team to really invest, let's say, in custom tooling? I mean, it's the same thing as in maybe like a 98, it was a kind of a real question that should we build our own DNS server? And like some companies did. And then the question was that, well, maybe at the end of the day, that wasn't actually the kind of the needle mover. Maybe that wasn't the biggest deal. And now the same thing with the MLOps. I mean, maybe there are some parts, some companies think that should we build our own, whatever it might be. And then like, maybe that's not actually like what moves the needle, but it might be something else.
Yeah, well, that is an interesting problem right now, which the build versus buy it. And one of the things that makes the problem more tricky is that the most companies are using cloud computing And I remember when cloud computing and you, I know we're kind of around the same time working in, different industries in the Bay Area, that it was controversial for a little bit. Like
Yeah.
cloud computing was like, oh no, the cloud, it's bad.
Mhm.
And then it's now become obvious that
That's
most
right.
people should use the cloud. But one of the things that's complicated is that, and I try to be really honest about it, is that I think the cloud by itself, some of the products seem like they're an easy fit to just grab. Like a good example would be AWS Step Functions and AWS
Mhm.
Lambda. They're just amazing. Like
Mhm.
like you put these things together, you build these tools, and it's just obvious that they're good tools. And there's
Right.
good instrumentation and all this really nice stuff about it. They're event driven. And then when you get into more complex products, I think the sometimes the cloud vendors, I think this is where they could benefit from specialists.
Yeah.
And I think a good example would be like, a data lake, S3 by itself, like, maybe you want something on top. And then,
Yeah.
or with Redshift, their data warehouse, like, well, there's
Mhm.
maybe there's like a specialized tool. And so I think that's one of the really big challenges, is that you have the cloud vendors, which most people are already on. Then you have the concept of build versus buy, and then you also have the concept of the specialized Indian platform.
Right.
And I think many companies are just really struggling, like, well,
Yeah.
which one of these three do I do, or do I do a combination of all of them?
Yeah, exactly. And I think like one interesting thing about the cloud is that uh, like we still have one noun, we call it the cloud. Although I think now after, I think it has been like 20 years of AWS, like it should be clear that there are actually multiple layers of the cloud. We have the low level services, like what you mentioned about the S3, EC2, like just works, like rather uncontroversial. Like, I mean, one can argue about the cost efficiency, but in many cases, quite cost efficient as well. Then we have this like a mid-tier services, like maybe RDS, maybe you get the database, like might be something networking, VPC, stuff like that. And then you have this like a high level services, like maybe SageMaker, and like kind of you have a quick site and like all these things that they provide. And now, well, kind of they are all part of the cloud, but I mean, like realistically, they are very different tiers of services. And I think like it totally makes sense for most companies to use the low levels. Many companies totally make sense to use the mid level. Then at the kind of a top level, I mean, yeah, maybe some cases, in some cases not. And I think having that more nuanced understanding of the whole thing helps. So.
Yeah, that's a good analogy, and it reminds me a little bit of going to either like a Walmart or a Costco,
Mm-hmm.
because in some sense they have a lot in common with, let's say, AWS. Like if
Mm-hmm.
you look at Costco or Walmart, in that if you go into a Walmart, I don't go into Walmart that often, but if I
Mm-hmm.
do happen to go into a Walmart, I'm always shocked at how much stuff they have. Like, wow, you have like literally
Yeah.
everything. There's usually a vendor for a product category. But to your point about the different tiers of, the lower level, middle, and higher end, especially on Walmart, you're not going to get a premium product typically.
Yeah.
Sometimes you will, but it depends on what problem you're trying to solve. If you're going to get some washer fluid for your car,
Right.
like, do you care if it's premium? Maybe most people don't care. They're like,
Right.
I just need some bugs are on my windshield.
That's right.
I just want to get some blue liquid.
Yeah.
I want to put it in there. Now, if it's I don't know, like you know, maybe some kind of a tire or something like that, and maybe you have a sports car. Maybe you don't want that their middle tier
Yeah.
tire. And so I think it's very common for people to get the staples at like a warehouse store,
Yeah.
right? And then there's just certain product categories where they're like, I don't want to buy, or let's say a grill. Like you go to Walmart, maybe you don't want the grill they have. It's not fancy enough. Like you want
Yeah.
a really good grill.
Yeah.
And I think this is the case probably for it. I think it could turn out like this for
I think so
data
too.
and
Yeah.
machine learning.
Yeah, I totally think. And, I think interesting, like kind of maybe overextending the analogy, but I mean, it really so much depends on the person as well. let's say, I mean, like, yeah, I mean, maybe it makes sense for everybody to buy potatoes at Costco, totally fine. I mean, would you buy your clothes? I mean, yeah, I mean, some people totally fine buying clothes at Costco as well. Some people totally think that's not what they want to do. I mean, it's about their like a style and whatever they want to signal. And it's the same thing with companies. I mean, maybe some companies, given how they want to leverage data science ML, I mean, like using some off-the-shelf easy tool may be totally adequate. I mean, some companies absolutely think that like given like what kind of role ML and data science plays at their company, I mean, it is not appropriate. I think that this is going to be the future, that it's going to be very diverse. I mean, it won't be one size fits all. And like if you think about the software engineering overall, I mean, like if you think that like is there like one way to do software engineering? No, I mean, like there's all kinds of things. I mean, how you do web development very different than distributed systems, very different than embedded systems. Also, like companies approach it very differently. So I think it will be same with data science MLs.
And you're, so I know not that much about your particular product, but one thing that I believed I had read was that there is a first party integration with Azure. Is that correct?
Yeah, no, I mean, super excited about that. So like we started, I mean, Netflix, as many people know, is kind of has been an AWS user for a long time. We started with AWS, and of course, like one of the questions we started hearing soon is that, okay, does it work also on Azure? So now we have Azure support, like a GCP support coming. So again, like goes back to this idea that at the low layers, at the lowest layers, like all these clouds provide actually like really kind of a good foundational services. And of course, there are interesting nuanced differences between Google servers and AWS instances and Azure servers. But I mean, by and large, I mean, there are other business reasons why you might choose one cloud versus the other. But at least like at that foundational layer, like you should be able to use them. And then layer like a systems like, let's say, Metaflow on top of these layers. And of course, like one thing that number of companies are now excited about is this idea of maintaining some kind of optionality like between the clouds. That of course there are like practical reasons why you might not want to have a full lock-in with AWS or with Azure. And technically, like you can at least entertain the idea that like we can even move between the clouds. Of course, that's not always that easy in practice, but that's a good idea. So
Yeah, I think the part of the I think the tight integration, at least in terms of being able to use a service in the cloud platform, to me has been one of the things I'm looking for when I'm using something. So, for example, I know a good example would be Databricks on Azure. I don't know if you've had a chance to use it, but the integration is very good.
yeah,
And that
right.
I think from a lot of my time now is I'm spending teaching machine learning operations or data engineering to students at Duke. And so when I'm teaching, there is definitely a part of me that thinks about, well, how do I just click a button and then have the students launch a cluster somewhere? And the fact that you can do that with Databricks for some of the like Spark stuff, versus if I had to go to AWS and go, well, I don't know if I want to play around with EMR. It's just,
That's right.
it's too much. There's too much. So the fact that you're going that direction, I do think is awesome, because at least from a teaching perspective alone, I think also from like companies that are doing it, they would be interested in this. But it's so much nicer to be able to essentially have like a rich integration on the cloud. And I do think if a company is doing MLOps and they don't, if they're creating an end-to-end MLOps platform and they don't have like that kind of integration,
Right.
I think you're in big trouble.
That's right. And I think it's a kind of this age-old question about software distribution, and like it is a fact that like the cloud is a distribution channel these days, and like that is where the software runs, and you better make sure that like it works really well and like you can like get started really nicely on that platform. So it's the interesting thing there is that I think that it has like a surprisingly deep implications to the design of the software as well, and like how you design the software to be cloud first versus something that, okay, I mean, we just take something that we built like 20 years ago and like we lift it to the cloud. I mean, that works, that's fine. But also I think that like the cloud really like provides some affordances that simply weren't possible before. The fact that like everything is so elastic, you don't have to think that, okay, I have these like a 200 servers and the whole problem is that how do we manage resources amongst the 200 servers? But I mean, really the fact that, okay, I mean, servers come and go, it's really ephemeral. and like kind of you can also like think about like who can access these servers very differently, because it's not that like a scarce resource and so forth. So yeah, no, I totally think that like that is the way of the futures.
Yeah, and to kind of build up on what you're saying, that to me there's three interesting things about the integration. One is that, to your point about the elasticity, I get a little concerned if I hear someone talk about kind of saying, "Oh, the cloud is bad for some reason." Like it kind of makes me worried a little bit because
Mm-hmm.
of the point you just brought up, which is that to me it's so obvious that elasticity is what you want.
Right.
I mean, if you design certain applications, correctly, they could be idle for huge percentages of the day,
Right.
and they only wake up to do some work, and so they can be extremely efficient. And so if someone is trying to convince your company to say, oh no, all of the cloud native capabilities, they're bad,
Yeah,
like,
that's right.
I think so. So to your point, I think that is, if I was going to build a checklist for platforms, I would definitely say they need to have a cloud native approach where you can do event driven programming, you can use elasticity.
Right.
The second one is, that's a big one too, is that it's once you have like a vendor already in your company, like let's say you're using AWS or using Azure, like it's so much easier
Mm-hmm.
to use a service that bills through the vendor, right? Like
Mm-hmm.
if your AWS bill was 2,000 a month and now it's $2,500 a month, people in your company are not going to create huge alarms
Mm-hmm.
and say, what are you doing, what are they like.
Yeah.
But if you're spending $2,000 a month, or I mean, I've been at companies where we spend $100,000 a month on AWS.
Right.
But if you're spending a bunch of money on AWS, the CFO might come to you and say, hey, what is this, who's this vendor,
Right.
what are you doing, like what was. So I think that's another one that I think companies that are not thinking the cloud first approach are not fully thinking through the problem, which is that they've already got the billing set up. So
Yeah.
it's going to be much easier for
Yeah.
them to sell this into their company, and you can get evangelists. And then the third, which I've more thinking of this from a professor, is that at some point the new people that come into the workplace are going to be the evangelists for things. And the last several years, I've been teaching thousands of students about cloud computing, and they all go into Google or AWS or Microsoft,
Mm-hmm.
and get jobs there. But if the companies that are trying to build these products are not where the same thing, the university, if they already have some educational resources for AWS, educational resources for Azure, like in the case of Azure, actually, one of the things that's really interesting about Azure is they have extremely good educational support. Like
Mm-hmm. Mm-hmm.
like AWS is very good too, but
Right.
I would say Azure's educational support is just amazing,
Yeah.
between like GitHub and between like Azure. And so you can create labs that are very easy for a university,
Yeah.
and then the students can just pick services and they can implement those services. So I think there's some non-obvious things that happen when you have a tight integration with the cloud that is very helpful to MLOps companies.
Yeah, no, totally, yeah. And actually, like maybe just to kind of a pile on the things you mentioned. I mean, it's just like also the security governance policies, and that's another eternal headache for companies. That like how do you make sure that like things are secure? How do you make sure that like we have our governance applied uniformly and so forth? And those things are really hard to enforce in like classical enterprise environment where everything is fragmented. And the fact that like let's say like on AWS and like similarly on Azure you have something like IAM, and like I mean it's complex. I mean these things are complex, that's true, but I mean at least I mean there's kind of this like common foundation, common language, how people can define these things. And like knowing how complex the whole like a cybersecurity landscape is today, I mean like I can't imagine doing it any other way these days.
Yeah. So I think, in terms of the question about what platform should I use or what experiment tracking system should I use. I cannot tell you how many people have asked me that in the last
Yeah.
year. They're like, what experiment tracking? They ask me, they say, what are you
Yeah.
using for experiment tracking? And I said, yeah, I've used a lot of different tools, but some of the stuff I do is more of like a solo developer. So I don't know if I'm necessarily the best choice for that. But what I would say, and is kind of what we're just talking about, is that to me, I would recommend a tight any service that does MLOps that has a tight integration with the cloud, that has, especially the billing is hooked up, and that it isn't going to be that difficult to cross train them.
Yeah.
I think that's the service that I would recommend.
That's right. That's right. And I think like another really important angle there is that if you look at the kind of a previous generation ML systems, I mean, like there's a kind of a legacy that goes all the way back to Mathematica and MATLAB and so forth. And like really like what was like a quite characteristic to those things is that they were really like walled gardens. Like you had a product, everything that like you did stuff in MATLAB, everything stayed inside MATLAB, and that was fine. And actually, it was in a sense like a very productive environment for certain kind of experiments. But the challenge was that like if you wanted to integrate any of those results to anything in the outside world, I mean that became really really hard. And now, like, given that the ML data science is not the kind of a research activity anymore, but it should become an integral part of the business. I mean, you can't be on an island anymore. Like, you can't have a system that's in this corner like we do ML. ML needs to be at the very core and the heart of the business. And that's why you need a system that like is not like that, okay, it only integrates, but I mean, it is actually like a very much interwoven in the whole like a business infrastructure that you have. And so it means that like whatever your engineers are using, I mean, it really nicely needs to integrate with that, whatever policies, whatever security, I mean, like it all needs to come together nicely. And that's why any kind of a notion like where you have like, okay, here's our like ML walled garden. I mean, that is challenging, because how are you supposed to produce business value with that? I mean, like the idea that you get CSVs out, I mean, that sounds like a very like early 2000s. So
Yeah. Like there was a company I talked to that was in real estate when I was still in the Bay Area. So this was maybe 2017 or 18. And when I was talking to them about MLOps, although I think people weren't calling it MLOps at the time,
right.
they were talking about putting models into production.
Right.
I think they mentioned that, well, we have a team that's in Texas and they're doing R. And then once a week, they ship us their R code.
Right.
And then we have like a Django app in Python, and then we
Yeah.
like do a bunch of stuff, and then we like put it in. It's like, wow, that sounds
No,
complicated.
I mean, and like honestly, I mean, many companies still do some variation of that thing, and I think that's the way how things used to be, and like, yeah, that's fine. What's so exciting is that it feels that we are taking kind of like a next kind of a step, or maybe even a leap forward. That it's not that like a handing over like R files or CSV files. And I think what it really enables is that, for one, I mean, you can apply ML and data science in many more places, because it becomes a much more integral part of the system. And also like the fact that it really becomes a part of the DNA of your company. It's not that, okay, data scientists do their data science thing and then like the rest of the business does the business, but it is actually the one and the same. So.
And what are your thoughts on one of I'll step back for a second. So one of the things I think is that's took me by surprise a little bit was how popular pre-trained models got. Like I've actually been interested in pre-trained models for quite some time.
Yeah.
Before Hugging Face was a big deal, but I didn't realize it was going to be this popular this quick. And now it seems like the platforms are going to have to integrate with this concept of pre-trained models. And if you think about, I would say like even SageMaker, like would be a good example. There was never, when SageMaker came out, it wasn't like, oh yeah, we support pre-trained models and fine tuning them. It wasn't like a core of the offering, or even, Vertex AI or anything. It seems like in general, there's been almost no talk about how you could use pre-trained models until the last several months or something. And so it seems like with companies, they're not only going to have to do the stuff we just talked about, which is, evaluate the cloud and evaluate vendors that integrate with the cloud, and which I think is a smart move. But then another thing that they may have to do is say, look, there's some things that we're going to train ourselves, because for whatever reason, we think we can do it better. But let's say 80% of the work might actually be pre-trained models, and we just need to fine tune them. And so we want a system that actually will work across both of those problem sets, right?
Right.
And I mean, do you have any thoughts about where that's headed with
Yeah, no,
ML?
I think that's absolutely true. But I mean, one interesting thing to note is that there are these phenomena that are absolutely common to us as a kind of a humankind, which, for instance, the language. I mean, like, let's say, like we talk the natural language, we use the natural language, and like that is by definition common. And hence, I think there's almost this like a law of physics that like it really makes sense to kind of share some of the kind of the foundational statistics about, okay, how does the language work? Another thing is of course computer vision, the physical world. I mean, like the way how we perceive things, the way how like kind of photos are created in the physical world. Again, I mean, like that's just like kind of so universal that makes sense to kind of share that foundation. Now, an interesting thing is that actually in the virtual world, in the abstract world, there are other phenomena that are not shared. And like, let's imagine that like you are like in the company in logistics, and like, okay, how does the trucking system work in the US? I mean, that is a very specific kind of a, like abstract world phenomenon. And it would be very hard to have a foundation model that this is the universal model for all logistics, or like this is the, maybe like for bioinformatics, I could easily see that could happen. But I mean, like there are many like a business, or maybe like you are selling like whatever, like apparel, and like, okay, like what are the taste profiles for apparel? I mean, again, I mean, it's quite ephemeral. So I think what will be happening is that like we have this like a bifurcation of two kinds of things. We have things that are shared, and then like we want to do transfer learning, we want to use foundational models and so forth. And then on the other hand, like we have a very business specific things. And I think that the smartest companies, what they are starting to do is that, of course, I mean, you want to leverage things that are shared, and then you want to specialize things that are very specific to your business. And then you combine the two, like, let's say you have some language embeddings, and you take the language embeddings and you use them to enhance your business specific problem. And kind of like navigating this space is something that like companies will need to learn to do in a very nuanced manner.
Yeah, I agree with you. I think that's a very good way you put that. And that it in a way, it just means that, if you're a software engineer, I guess in particular, that you in some sense have intuition that is a good intuition, because we all the stuff we talked about, DNS systems, e-commerce systems. I remember when mobile, very clearly remember what happened with mobile and the whole, how it became a big deal, and it wasn't a big deal, and then now it's commodity. And I think one of the things that a software engineer does is they know that they have to adapt to new things, and they take the best of the components that are available and they integrate them. And it does seem like, I agree with you, with the pre-trained models, there's going to be some parts of the pipeline that it just doesn't even make sense to do. Like, if Google created a billion parameter model that is very good at summarizing things, why would you do that? It doesn't. You would just take it and you would use it, but it could just be something that now becomes part of your pipeline. And this is what I've said to many people that are I guess maybe not as experienced as software engineers, because a lot of the data science folks are more like from the academic world. And so some of them don't have our experience of building systems. And a lot of times they are, I think, are shy away from automation. And what I've said to people is that no, that you want the automation, as much automation as possible, because what it means is that the problems that are easy now go away.
That's right.
Because, and you don't have to spend time on sentiment analysis anymore. It's solved. You don't have to spend time on summarization. It's solved. You don't have to spend time on translation. It's solved. Now, the really tricky problem that's unique to your organization, you can spend a lot more time on it.
That's right.
The parts of the problem, even the problem itself, that are boring and tedious, like hyperparameter tuning, like, do you really want to do that?
Right.
Like that goes away.
Yeah.
So I think it's just the natural life cycle of building systems is you when there's a new technology that makes it easier, you adopt it.
Right.
And then two, in the unique problem you're solving, the parts that are automated, of course, just adopt it. Just use whatever tools make your job easier.
Yeah. No, and I think that the key thing there is of course, the kind of the perspective and like kind of keeping the eye on the price. And like, of course, like if the idea is that, okay, I want to go to work and like the job is that I sit down on my laptop and do hyperparameter search. Of course, like if somebody comes and says that, okay, I mean, like here's a tool that does it automatically, it feels kind of threatening. But if the idea is that, okay, I'm here to kind of build some amazing user experiences, I'm here to kind of help my company to make more money, I'm here to maybe help myself make more money, advance career, I mean, then of course, I mean, like probably like just focusing on hyperparameter tuning is not what you are supposed to be doing. And I think that there's always the fear that like somehow maybe there's a bit of like innate fear that like, well, I mean, maybe the thing that I'm good at will get automated away. But if software engineering is any proof, I mean, like it won't happen. I mean, it's just that like kind of the level of expectation just like a shifts one level up. And like there are people who used to be whatever database administrators, like, I don't know, like 20 years ago. And like now they kind of do similar things, but maybe with the cloud or something. So yeah, no, I don't think that like any data scientist should be afraid of automation. And indeed, it is very much of your friend. And I think when I have worked with data scientists, I mean, like at the end of the day, everybody loves the fact that like the things we do actually benefit people around us. And like it is so rewarding when you see that the thing that you build, the models that you have developed actually like kind of make the experience more amazing, like kind of produce something amazing. So I think that, and the automation is the key to that. So I think that the faster people can get to that feeling, the better.
Yeah, I agree with you. And the other thing I think that's interesting about the hyperparameter tuning is, and one of the things I've said to some people about this problem is that if you do everything yourself, let's say you can train one model a month, or if you embrace the automation, you could train 100 models in a month,
Right.
or maybe 1,000. And then if it goes into an experiment tracking system, you just evaluate it. You just look at all the different experiments, and you look at all the different techniques that were used. And in a sense, it's like, it would be foolish not to use that.
That's
like,
right.
why would you not? I mean, that's science. I mean,
Yeah,
that's
yeah,
basically
that's
how it's a scientific method.
That's right. And I mean, this is the same discussion we have had like in the early days. I mean, people said that, of course, I mean, like I want to code everything in C. I don't want to touch Perl, Python, like whatever, because I mean, like, oh my gosh, look at the string handling. I mean, I can do it so much more optimally when I do it by hand. And then at some point, like you kind of realize that actually like counting the bytes really doesn't make any difference, and really doesn't make any difference at the end of the day. And then you realize that I can just like embrace these like a higher level abstractions, and I can do so much more, and I can be so much more productive. And like, I mean, it's just like all around so much better experience.
Yeah. And it's funny. I've noticed when I work with people that are in the low level, like they're, let's say you've got 20 years experience and they're C++ programmers. It's interesting because they see the world in a very different way.
Mm-hmm.
And in some sense, the mental skill necessary and the exertion mentally to think about, all the things that are happening in a C++ program, and, oh wait, did I allocate this memory correctly? What about that thread? Is this thread, is it, is it locked, or, all these different things that these are obviously very intelligent people, like
That's
extremely intelligent people. But I do wonder sometimes when I'm working with, I mean, there's cases where you have to have these C++ experts because it's necessary, like they're working on something. But it's sometimes when I'm working with someone where it's not as obvious that the company should be doing C++, for example, I do wonder, like, wow, that's a brilliant person. What if they were just a layer above?
Right.
Like,
Yeah.
like what could they come up with?
Yeah, that's right. But, I mean, one thing that I think it's absolutely like necessary to mention in this context is that I actually think that like we probably need more C++ people in absolute terms than before, because I mean, honestly, I mean, I really do have to thank everybody working on the internals of TensorFlow and internals of PyTorch. And I mean, those things don't happen by themselves. And of course, like we are only able to kind of stand on the shoulders of those C++ giants that actually created these libraries for us. And I know that there are amazing, amazing low-level hackers, let's say at NVIDIA, creating like whatever GPU drivers and like CUDA and so forth. So, I mean, absolutely. I mean, and if that's what you want to do, I'm sure that there are many, many opportunities. But what it means is that, of course, I think that there's this like kind of a relationship that there will be 10 times more people that are needed like at the layers above. And like if you think about those like a real world kind of like more like a human facing interfaces like versus the machine facing, I think that like we just need way more people. And again, I mean, it's just exactly the same thing as with the web stack. I mean, still of today, I mean, I'm pretty sure that there are people who actually create DNS servers. I mean, somebody's hacking all that DNS stuff even today. But I mean, like there are probably, I don't know, like how many, like 100 people in the world. And then there are like 100,000 building web applications on top of that. So the same deal with data science.
Yeah, I think some actually some experts from Netflix, maybe even know some of them, have a company called NextDNS. Have you heard of that company?
No, actually, I haven't. But
Yeah,
yeah,
it's actually a very interesting DNS service. I use
right.
it, and the reason why I use it is that it gives you all these additional features in DNS. So like I
Yeah.
used to run DNS servers like a long time
Yeah.
ago.
Yeah.
But I can just do it all by just going to a web interface and just clicking some buttons and they give you. So yeah, to your point, how many people are working on commercial DNS servers? Yeah, maybe it's 100 people. So in a sense, you better really be sure, that's you're good enough, right, to do that. And I
Yeah.
agree with you. That like you're right. There's probably even more of a need for the low level C++ programmers to make TensorFlow even better, and those kind of libraries. But on the flip side, if that's not what your company's doing, building deep learning frameworks, then maybe get out of there.
That's right. That's right. And I mean, like, it's really like much about your personal passion. I know like amazing individuals who love doing that would never do anything else. And I love that they exist. I mean, I hope that they get paid a lot and all that stuff because everybody else benefits. And that's the magical leverage effect of software, that like one guy like builds the compiler, like creates the GPU driver, and then like kind of everybody else can like just use it. So it's just magical.
So one question I have for you is what, so you're originally from Europe, is that correct?
Finland, yeah.
Okay. And one of the things I've been noticing is that we're getting this the world is changing very rapidly, in that even in the last several years people can live anywhere they want.
Yeah.
And what is kind of interesting is, I wonder, in the cases of where things are going with AI and deep learning, whether companies also need to be careful about the platforms they're using from a regulation standpoint, and also where the people are that are using the technology. Because if you're, let's say, in the European Union, you for example can't move data to the US, right? So you can't physically work on the data. So if you're for example, don't have an easy way to handle that, where the cloud vendors do actually make it fairly straightforward. You just use the data center that's in the EU, right? And you use that one. And so that's one aspect I think that's kind of interesting, that would be interesting to get your view on. And then the second one is that I suspect there could be a like a, what's the word, like a kind of a retraction, or a like a trend towards looking at AI with more of a rigid view of what the impact is on society. Because I think when it first came out, I think we didn't really pay attention that much to all of the externalities of what's happening. And I think if you look at a product like the Netflix recommendation engine, really, there's not a lot that can go wrong, really, right? I mean, it's movies, it's entertainment, so it's at a layer that's neutral. But if it's something where it's a non-curated source, like it's YouTube or it's a Facebook feed or whatever, if you're recommending all this stuff, it seems probable that there will be a day in the future, maybe it won't be this year, maybe it'll be 5 years from now, it'll be 10 years from now, where let's say the EU says, I want to look inside of your recommendation engine, and I want to exactly show me what you did, and I want to know what the impact was on society, just as one example. And then the same with the autonomous vehicles, right? Where based on, and I've met and I know some people, and I won't say all the different people I know, but I have a feeling that the autonomous vehicle industry as well, that there could be a little bit of a pushback as well, where people say, hey, what is your car doing? And
Yeah.
why
Yeah.
is it doing it? All these different steps.
Yeah.
And so I guess the question for you is that it seems like this is yet another reason why a company, especially if it's a profitable company, should be pretty careful
Hmm.
about building something themselves versus
Hmm.
maybe using a platform, and especially a platform that's on the cloud, because they're mitigating some of that black box regulation risk by using an
Yeah.
Indian platform. So yeah, do you have
Yeah.
any thoughts on that?
Yeah, yeah. No, I mean, like obvious, like a huge questions that are like we are like facing society wide these days, and I think, I mean, like one like kind of a core belief that I have is that I don't think AI or ML or data or anything like gives companies any excuse to escape responsibilities. So in the same way, if you're a company and you are building a product that, let's say, hurts people or discriminates people or anything like that, I mean, like obviously, like if you make those choices consciously, if you tell your PMs that let's create a bad product like this, I mean, that's bad. I mean, you are making a deliberate choice.
Sure.
And the fact that like you're using models, I mean, it's not an excuse. You can't say that, oh, I mean, we used AI and hence, I mean, like somehow like we are not culpable, we are not responsible. I mean, it doesn't work like that. At the end of the day, they are tools, they are methods, they are techniques like anything else. And now a challenge is, of course, that like our understanding is not yet at the level that like all companies are necessarily capable of making those informed judgment calls, that what exactly are we doing, and that is a problem. I do think that it is probably actually a good idea to have and foster enough diversity that there isn't exactly that like top-down regulation that nobody can do this or nobody can do that, but it more so that like as with any other choices that companies make, I mean, companies they have different like risk profiles, as you pointed out, like let's say Netflix recommendations. I mean, there's a case to be made that it's maybe a bit less risky as like self-driving cars, like, and hence I would hope that these companies then approach the problem differently, and there's a good reason to do so. But in both cases, they have to be like a quite conscious. They have to acknowledge the choices that they are making, and I think that this is just a kind of a muscle, kind of organizational muscle that's missing in many places. That, I mean, this far it has been that, okay, I mean, we have the data scientists, they just do something and like, yeah, well, I mean, like we seem to be making more money, so I mean, that seems to be fine. But of course, I mean, that can't fly in the long term. And also what you mentioned about the different geographic areas, the fact that there will be different regulatory profiles. The EU may regulate AI differently than US, probably very different than China, very different than some other countries. And I think it will be exciting to see. It's a huge experiment that's ongoing. But I mean, the main thing is that, like, I mean, yes, I mean, everybody is responsible. And I think even for individual data scientists, I mean, the fact that like this is somehow mathematical or model based, I mean, it's not an excuse to do anything that like wasn't acceptable in the past. So
Yeah, and that's the part I think that is something that I don't know if enough people have thought about, is that if your company is doing AI and you have an event in the future where there's a problem, uh, is the thing you did an existential threat to your company?
mm-hmm.
Now, if you have a platform that you're partnering with, and as the industry gets more mature, and people are getting more and more, I'm sure researchers are going to come up with better techniques to explain models, and all these kinds of things, that you can just leverage all that. But if on the flip side, it's kind of like with the when the cloud first came out, there's been so many data breaches. I mean, like,
Mm-hmm.
and in a sense, like, many of them were pretty preventable, right? Like,
Right.
someone takes a bucket in S3 and it's got 100 million
Right.
people in it, and they just let everyone have it. It's like,
Right.
wait, I mean,
Yeah.
like that. And so I think the same thing could happen with companies that are doing machine learning. It is, on one hand, it's good, yeah, get models into production, but if you don't have a platform and people train on the platform, and in some maturity, that I think it could really be a big problem. And because
Mm-hmm.
I don't know
Yeah.
if it would be right now,
Yeah.
but especially as the regulations, and it could be from the EU, because to be totally honest, I think the EU has done a better job
Mm-hmm.
with regulation than the US.
Yeah. Very
And
cultural difference there. So
yeah,
yeah.
and if it is the case that let's say that companies that are doing classification for credit, like
Mm-hmm.
that, maybe now the regulations will be the regulation of the future will be different than the we are now. And what if the explainability requirements are such that you basically would have to delete everything you did, right?
Yeah.
And so I think that is something that I just have not heard that many people talk about, but
Yeah.
that companies should be thinking about future regulation and how they would handle it if they did get additional requirements about explaining their model.
Yeah, no, that's true, and I think it like the understanding of those issues, I mean, is there, but I mean, it's very unevenly distributed. I know that like there are some companies who are very acutely aware of the situation, take it very seriously, are quite sophisticated about it. I mean, some decide to be very conservative because they want to avoid the risk altogether, and then like some companies are more like laissez-faire. I mean, like yeah, I mean, like let's see what happens, and I mean, arguably, I mean, it is the same thing, of course, like with other things as well. That like, yeah, I mean, that just depends on the risk profile, the kind of overall like a level of sophistication and responsibility at the company. But the main thing is that that I mean, like, I don't think that like any fundamental way AI and ML gives anyone any excuse to kind of behave any differently. And I think like one of the interesting challenge is, of course, to kind of on the other side, like how do we police these things? How do we detect? I think that that's one of the biggest challenges, that the failure patterns become so much more subtle. That, like you mentioned, for instance, the kind of the credit risk or something. I mean, like, let's say if there was a bank and they consistently declined to give credit to certain people. I mean, well, maybe that would be quite obvious and there would be some journalists that would see that. But I mean, like, let's say if there's a subtle bias, I mean, maybe let's say it's a kind of a 60-40 type of situation. How do you detect that? And that is an interesting challenge. And I think also on the other side, like when it comes to journalists and like, of course, governments, everybody else, I mean, yeah, I mean, we do need to become more sophisticated and also like policing and like kind of eyeballing that, like what is going on in the industry. And I think a good example there is like, for instance, I think it's like a SEC like looks at the kind of insider trading in the stock market. I mean, like people try to be very clever with that. I mean, they are like also the other side. I mean, it's kind of an arms race type of thing. Like the sides like becomes more clever as well. That unfortunately, I think that that's the world we are entering. That yeah, I mean, there's the arms race, and like both sides need to become more sophisticated.
Yeah, the AI stuff in America that I think is the two ones that I think that are a little bit troubling are, I think, autonomous vehicles. There are some real question marks in terms of the ethics of it, and in particular, like if you are legitimately thinking that your technology will save human lives, is it really up to you as the owner of
Yeah,
the company to say, well, it's okay to kill 2 pedestrians
that's right.
if we
That's,
save 1,000
yeah,
drivers? I would say no. I mean,
yeah,
it kind of depends on, like, ethically, but the pedestrians didn't sign
yeah,
a waiver that says, I'm okay with being in an experiment where I might die to save 1,000 people. And
yeah,
and actually, I heard a really good analysis of this from the Sam Harris podcast. He was talking to somebody about ethics, and he mentioned the classic example of the trolley problem that's more realistic is that if you went to your doctor, who's a surgeon, and they noticed, I'm almost 50. So they say, oh, look, you're 50. You had a good life and your organs are great. And I
yeah,
know 5 people who could use them. and they
yeah,
just kill you and they just take your organs and they
yeah,
give it to,
yeah,
like, ethically, the doctor can say, hey, look, I saved 5 people's lives
that's
and there's
right.
only one I killed. Right.
Yeah,
But most people wouldn't want to live in that kind of a society. Like, I'm stealing that analogy from, and I
yeah,
think that the self-driving car has a little bit of that too, where
yeah.
I think I hear a lot of times, oh, we're saving lives. Well, but if you kill a pedestrian, they're not in a car. Like,
That's right. That's right. Yeah. No, and I think, well, the one thing about self-driving cars is that they are so visible and there's so much interest towards them that like people are really scrutinizing self-driving cars and companies. So, well, what actually like gives me maybe more worries is that there are so many other areas of life that don't get the same level of scrutiny and like don't even get the same level of regulation. I mean, like there's actually plenty of stuff happening in healthcare, plenty of stuff happening in finance, and like, I mean, it's crazy stuff that's going on and nobody pays attention. So So yeah, no, I mean that is the case, and I do hope that like we do need to increase the level of sophistication, like on the people who pay attention and like make sure that they have the tools also. Actually, they should have, I mean, the one thing also, like why I've been always excited to kind of make these things available as open source is that it is a worrying world, like where it is only like a few large companies that have access to the best tools and have, like, let's say, access to the large enough compute so they can do these things, because that creates a very lopsided situation that then like even like the people outside can't even like quite understand what's going on, and they never have the capability of doing so. So at least we should have a level playing field, that there's at least some kind of a capability that, okay, the same tools are available on all sides. So I think that helps a bit. So.
Yeah, and I think there. I used to be less worried about the centralization of power for corporations, and I guess as I've gotten older and I've seen the implications of centralized power, is I have been more worried, and I think you're right. Like if you're if a few companies are controlling certain segments, then there really could be some bad consequence. And I think we've seen this for sure with recommendations that I think mostly from the largest social media companies, that the centralization has not necessarily benefited society, and there maybe there will be even regulation in the future about that. And then the same as if there was only one company that was able to do cancer screening. Yeah, who knows what is there a perverse incentive for certain screenings to not be taken seriously, or all these ethical things that happen, where if you're able to reproduce what the larger companies are doing through open source. Yeah, I think that's a very good point you bring up.
Yeah, and then it's not only the code, but it's also data. So of course that's the interesting side of the equation now, and that's the difference compared to the previous open source movement that of course was hugely successful. I remember in 1990s everybody was super afraid of Microsoft and the Microsoft being so dominant with operating system. But I mean, that problem kind of went away. I mean, the operating systems kind of stopped mattering, and anyway, like Linux took over the world through free software and open source. But now the data is a kind of a new element in this equation, that it's okay. So the code is available, and maybe the compute is available, like through the cloud, which is amazing. But I mean, now the kind of the missing piece is about the data. How do we? I mean, and of course, I mean, like recently, I mean, like just over the past few days, there has been a lot of discussion about the Copilot GitHub and like the fact that they are leveraging like all the open source code, and like how do we think about the copyrights in this context? And like in some sense, it is kind of a public information. I mean, anybody should be able to access it, but realistically, it is so much more easily accessible by Microsoft and GitHub than anybody outside. So those are really interesting questions that like we are facing. So.
I agree. I guess in terms of people wanting to use Metaflow, what are 3 ways they can use it? Would it be correct to say they can just go to Azure, launch it, and it's part of the building system? 2, they can just download it from GitHub, and then 3, they can just go to your website. Is that would those be the 3 ways, or are there?
Yeah. I mean, like pretty much the easiest thing is that you go on your laptop, you write pip install Metaflow. I mean, the easiest way to get started. Documentation definitely available. I mean, one thing that also like we strongly believe is that like usually the path that companies should take is actually quite gradual. That like, I mean, and I think that causes a lot of like unnecessary anxiety, like with students and like with companies, that there's a feeling that, oh my gosh, like Google is there, Netflix is there, and like I'm here, and there's such a big gap. Yeah, sure, but I mean, you don't have to be Google, and like that's not what you should be like striving towards, anyways. But it's more so that, okay, I mean, like I do pip install Metaflow today on my laptop. Okay, I'm actually like able to kind of do much more than I was able to do yesterday. Then what are the next things? Okay, I mean, I can start doing this on Azure. I mean, okay, I execute this Terraform and I can do this on Azure. That's a step forward. I mean, now the next thing is that like, how do we make sure that this is reliable? It runs every night. Okay, I do the next thing, and so forth. And you kind of take these baby steps. And I think like one thing that often goes underappreciated is that it's not only about the technical stuff. Do we have the technical capability to go from 0 to 100 like in a day? But it's also the organizational muscle. That, let's say, I mean, like, what does it actually mean to build a model? I mean, what does it mean to actually like a test that it actually works? What does it mean to have an A/B experiment? And all these things, I mean, it oftentimes involves like shared understanding between multiple people, like the data scientist, maybe the product manager, maybe the leadership. And that doesn't happen just by people installing anything. So I think that's why, I mean, taking those like a step-by-step approach is kind of probably healthier for most organizations.
Yeah, I agree. I think that, one of the patterns that I would say is an anti-pattern for end-to-end MLOps is if someone can't try out your products by doing like a pip install or downloading a Docker container or something,
Yeah.
that's bad, right? Because
Yeah.
because if there's only like a web sign up form, then especially for like a student, like let's say a student could potentially be an evangelist for your product, right? And
Yeah.
if they can just pip install it, then they can try it out in a class project, and then maybe they build a portfolio on GitHub, and then a company that hires them goes, oh look, we're looking for someone with Metaflow experience. So it feels like that feedback loop. There should always be some open source component to it, so that you're basically letting people actually learn your product for free, right? And they could potentially be unpaid evangelists.
Yeah, no, and I think that this is kind of the big learning that we have had, like as a whole, like industry over the last, I don't know, like 30 years, that like there's a reason like why, let's say, all databases are open source these days, and there's a reason like why there's a bit of an expectation that like, well, I mean, maybe operating systems are oftentimes open source, and like many other pieces of this, especially the infrastructure stack. And I don't think that like ML like will be any different. Now, there are like a concerns on top of the stack that like many companies decide that, okay, I mean, we want to make sure that this integrates with the Active Directory. Okay, maybe we pay someone to do that. And I think that that's, of course, the kind of a business model that like seems to work well for many. So that's fine. And that's, of course, like kind of what we are doing on our side at Outer Bounds as well, that, okay, there are companies who are really serious about this. They don't want to have like their own engineering team to do all this for them. So that's fine. Like, we are happy to help. But then like for those companies who feel that they are capable and interested in running everything in open source by themselves, I mean, that's great. I mean, like super welcome for everybody to do that as well. So.
That's good. Yeah, you definitely convinced me to play around with pip install Metaflow.
Yeah,
I like that.
awesome. Yeah,
And you also wrote a book recently for Manning, right? And
yeah, that's right.
is it basically teaching people how to use Metaflow? Is that the essence of it?
Yeah. No, I mean, like the whole stack kind of like, I mean, the idea was that, okay, it's not only like the Metaflow, the missing manual type of thing, but I mean, like also like having a bit more like a systematic, like a point of view that, okay, so how should we think about the whole stack? Like, what are the essential components? I mean, like, even if you don't use Metaflow, I mean, like, what are things you should be thinking about, like when you think about MLOps? And I know that this is, of course, something that like you have been advocating and really helping people to understand that, okay, I mean, like, how should we think about data? How should we think about compute? How do we train these models, so forth? How do we think about the orchestration? These are not like a singular like a processes, but I mean, it's a kind of a whole like a workflow of things. And how do we think about the versioning? It's not the kind of a single kind of a shot thing, but I mean, it kind of grows over time, and so forth and so forth. And I think that the much confusion today like comes from the fact that like people don't have a consistent mental model, but it seems that, oh, I mean, there's the experiment tracking thing and there's the deep learning platform, and like how do these things like work together? And like if you kind of take a few steps back and like you see that, okay, what are really the foundational needs here? I mean, okay, we need data, we need compute, we need these things. So I think it's somehow, I mean, the kind of a dots start getting connected. At least I would hope so.
And I would say in terms of the other thing that I've been very curious about with end-to-end MLOps is that it seems like this love affair with Spark and a love affair with virtual machines are maybe misplaced. I mean, just my opinion,
Yeah.
which is
Yeah.
that I'm hoping that the MLOps platforms of the future are more event driven, and that they're lazy, right? Like
That's right.
where you don't have to actually spin up huge clusters. And I mean,
That's right.
and that might be another, because I haven't really. I'm going to right after this. I'm gonna play around with Metaflow. But what are your architectural thoughts around the more event driven versus the Spark or virtual machines?
Yeah, I think that there's a bit of an evolution there. And I mean, like for those of you remember like the whole like a Hadoop MapReduce big data boom, like that maybe started 2004. Google published the MapReduce paper. And like, of course, and that even like was motivated maybe by the previous generation, like high performance computing systems and so forth. But all of them were built with this idea that like you have a finite resources, you have few racks of computers, and then like you need some kind of a management layer to kind of basically like hand out resources like from that like a finite fixed cluster. And that was like what Hadoop was kind of the big innovation there, is that like you can use commodity hardware, like you don't need to buy like from IBM. So that was the big innovation 2004. Then Hadoop kind of was pitching that idea, and then like a Spark like really directly evolved. I mean, they still like use many of the internals of that system and kind of took one step forward. And like, I mean, like Spark is a big improvement over Hadoop. I mean, no question about that. But I think like now we are taking a step beyond, and like especially like the big architectural difference there is that like we are not dealing with these fixed size clusters anymore. And exactly like you said, I mean, like now compute is becoming more ephemeral, and like most data scientists out there like just feel that, okay, here's a cell in a notebook, here's a Python function, somebody just go and execute it. I don't care how it happens, I don't care about servers, I don't even care about Docker, but here's a Python function that includes the business logic that I care about, somebody go and execute it. And I think that is the right level of abstraction as of today. And I think that that's like what the future systems will be like. And it's kind of like a surprising that this has taken this long, because if you think about it, kind of a no-brainer. I mean, and it's not only that, but also the fact that like the code that you write should be rather idiomatic Python or whatever language it might be. You should be able to use off-the-shelf libraries. You don't want to kind of rewrite. There was like, I don't know how many PhDs were written about how do you do machine learning on MapReduce. It's kind of an interesting intellectual exercise, but I mean, not what most people want to do. I mean, just let me do the simple, straightforward thing. Let me use pandas, whatever it might be. And then it just works. So I think that is definitely the direction. So, and
is that something that you're kind of going towards with
oh yeah,
Workflow?
100%. I mean, that has been the idea since the very beginning, that like as of today, like we integrate with the system called AWS Batch. So you write a Python function, then you can use AWS Batch, let's say on AWS, and like the same thing with Azure, like it just like runs on like AKS or something, and you write the function as a data scientist, the function gets executed, and that's all you have to care about. And most importantly, I mean, you don't have to learn a new paradigm, you don't have to learn new abstractions. And also like engineering wise, I mean, the big deal, and like Netflix used to be very, very sophisticated with Spark. They had dedicated Spark teams and so forth. And always the kind of the pain was that when something failed, are you able to understand what failed? And that was always the problem with these complex distributed systems, that like, well, when it worked, it was nice. But when it didn't work, I mean, it became like just like impossible to understand. And that's a big difference with this function approach, that like typically when something fails, I mean, oftentimes it might be actually something in your business logic. Maybe your data has nulls or something, but then the errors are understandable. And like you are able to see that, oh, I mean, now I understand. I mean, this is because of the whatever pandas thing I did, or like whatever data I had, and I can debug it by myself. And it's not some like a cryptic Spark error. So.
Yeah, and you if I remember correctly, you basically built a competing MapReduce system
That's
called,
right.
was it Disco, right?
Yeah, that's right. Yeah, no, I mean, like I'm happy that you remember like on Erlang. So I mean, because of out of this frustration that even back then, I mean, you know, it's kind of funny now with hindsight that like we had this idea that, look, I mean, people probably would like to do this in Python instead of Java. I mean, back in, let's see, this was 2008. That was a controversial idea. Nobody took Python seriously back then. So I mean, like, you would like to do machine learning in Python? Are you crazy? I mean, nobody does that. So a bit early, but I mean, yes, I think that those ideas like still like very much like ring true. So.
Yeah, I think I agree with you that the function approach is the future, and that's why things like AWS Batch, Lambda are just they just make sense. And funny because I wrote right as I left working at a company as a CTO, I got into consulting, and one of the companies I worked for, they wanted me to build a computer vision pipeline from zero that used some proprietary computer vision technology that stitched together VR systems. So like they would take like 96 camera shoots and then stitch them all together, and you could walk around and so basically there's a need for like a heavy compute infrastructure, and it had to do it very, very quickly, and it had to work around the C++ code. And so what I did was on AWS built a essentially AWS Batch before it was available, because AWS Batch wasn't available at the time.
That's right. Yeah.
And I wrote a pretty cool like batching system that handled like thousands of spot instances, and the instances would wake up and they would talk to SQS and get their work. And then it had to have all. I had a Lambda function that I called the arbiter that was sitting and watching everything and balancing things if they got out of hand and telling certain jobs to end. And anyway, it was a cool system that I had a chance to build. But then they built AWS batch. And I was like, well, I don't even need this anymore.
Yeah, no, and like honestly, I wish that they kind of a dirty secret like that AWS doesn't want you to know is the fact that like AWS batch doesn't cost anything extra over the EC2 instances. And that's actually like a key difference to SageMaker, where you have to pay 20-30% more, like although they are like the same underlying instances. So it's not exactly kind of a cash cow for them. But I mean, that is kind of the abstraction that like many people in this field like kind of need and want. And that's why we kind of want to provide an easy interface for that. And like, of course, I mean, that is just an underlying component. You can get the same experience. Like, let's say if you have somebody takes care of the Kubernetes cluster for you. So, I mean, there's nothing magical about that, but that kind of abstraction is really kind of, I think that like it just makes sense, like in the context of building the software. Now, I think like some people would even push back and say that, why would you even worry about writing the functions? I mean, it's a natural question that, okay, let's not worry about the servers, let's worry about the functions. Then the question is that, okay, why should you even worry about the functions? And then the idea is that, okay, maybe there's even a higher level, maybe declarative interface or like maybe drag and drop something. And at least my experience this far has been that many of these real world machine learning pipelines actually have to have a good bunch of business logic. And you have to be able to express the kind of the business rules, kind of the reality that the business operates in. And that's just like a hard to kind of have in a config file, in a JSON, in a YAML, or like maybe in a graphical like interface either. So I think that there's a case to be made that like, yeah, I mean, some Python code is actually probably quite handy, but I mean, not much more infrastructure than that. So.
That's interesting. And I guess maybe a last question I would have is, are you planning on doing any kind of a certification? So like a lot of things I push for students, I call this a triple threat, which is they should get a good degree somewhere, they should build portfolio, and they should get certified. And so in MLOps, there's not a lot of certifications right now. So is that something you've considered? And
yeah, no, good question. Actually, like, yeah, no, I love the idea. And I mean, we have a super active Slack channel. I mean, like there are over like 1,500 people like asking questions all the time. So kind of people like a bit of like a self-certified themselves. But I mean, I love the idea of like actually like kind of acknowledging that this person has reached a certain level of knowledge. So I mean, that's a good idea, definitely.
Cool. Well, I learned a lot, and you got me excited actually to try out your product. So
awesome.
I'm looking forward to playing around with it.
Yeah, no, great questions. I mean, always great to chat with you.
Yeah, and I enjoyed spending your time, and I'm sure we'll talk again soon.
Awesome.
Okay.
Cool.
Talk to you later.
Thank you.
Bye.